Welcome to Developer Service YouTube channel. On today's video, we're going to be forecasting the weather with the Zambretti algorithm and using the weather data from Open Meteo. So we'll be getting the weather data for the last week. We'll also be getting the elevation for a specific location. In this case, it will be London. We'll be getting the last temperature measurement for that location. And using the Zambretti algorithm, we're going to be forecasting the weather for that location, which in this case is fine with possibly showers. Let's see how we can build this weather forecasting application. So let's start by introducing some of the components. We have the weather data comes from the Open Meteo Weather API, which is a free API. Does not require an API key for non-commercial use. So for personal use, it's completely free. It has several APIs that we can use and a very high resolution. One of the APIs that we are going to be using is the forecast API that allows us to get the forecasting data for a particular location, for a particular time frame. As we can see, we can also define several of the items for current weather, but also the forecasting weather. And being a free API, we can also quickly test the API and see the data getting returned. Besides the weather API, we're also going to be using the elevation API because we're going to be needing the elevation to forecast the weather. Again, we can just preview the API for a particular location. So it will receive the latitude and longitude, and it will return the elevation. For forecasting the weather, we're going to be using the Zambretti algorithm, which is based on the Zambretti forecaster, which is a weather forecasting instrument that it was used to interpret the reading of the barometers. And it had, despite being very simple, it had a 90% accuracy for 12-hour forecasts. And then, of course, that gives the origin to the Zambretti algorithm that has been implemented in several electronic forecasters and also available in Python as a Python package, which we're going to be using the implementation of the Zambretti API. All links will be in the description, and that, of course, can be installed with pip. So that's what we're going to do, to be using this Python implementation of the Zambretti algorithm. Now that is all the components that we're going to use, let's see what we need in terms of libraries. So of course we're going to need the request library because we're going to be using the requests to do API calls. We're going to be using pandas because we're processing the API data with the pandas library. Matplotlib because we'll be showing later on a graph of the temperature, humidity, and also the pressure. And of course the Zambretti API algorithm, as you saw. So you need to do the pip install of all these libraries. I've already done the install in this case, and all of them should be installed by now. And so let's now take a look at the code. So our code, as you can see, resides in one main file, the main.py file in this case. So we start by importing the different libraries, as I mentioned, request, pandas, matplotlib, date time, so we can adjust the dates, and Zambretti API algorithm, as we saw before. Then we define the location in the date range. The location is defined by the latitude and longitude. In this case, we have the coordinates for London. We're going to be defining a date range with an end date, which is today, and a start date, which is 7 days back. So we're going to be getting the weather data for the last week. We're going to be formatting the date times into strings that is required by the API. And then we're going to get the weather data from the Open Meteo API. And this is the URL endpoint for the forecasting API. We need to pass several parameters, of course the latitude and the longitude, as we defined before, the start date and the end date. We pass also the time zone, and then we pass the specific items that we want to get from the last week, and we want to get the hourly data of the temperature, the relative humidity, and also the surface pressure, meaning the atmospheric pressure. The 2m represents 2 meters, and that represents the accuracy that is available for both the temperature and the relative humidity, so it will be accurate for a radius of 2 meters. We're going to be requesting that data, doing a very simple get request with the URL and the parameters, and that will return a JSON. So the JSON response, we're going to be instructing the hourly dictionary, which contains all the hourly information. We're going to be storing that into a DataFrame as we're using the DDF. We'll be making sure that we'll be converting the date time the time information that comes from the API into a proper datetime object, and we are going to be using the DataFrame to datetime for that. And we are going to be previewing the data, as we saw in the opening of the video. It's going to be showing the 5 last records from the DataFrame. So next we are going to be plotting the weather data with Matplotlib. So we create our figure, we define the current size, we define the different labels that we want to have. In this case, the temperature, the relative humidity, and the surface pressure, with of course the appropriate label and the appropriate color. So the x-axis is going to be the time, so it's going to be the days. The y-axis is going to be the measurements, in this case the temperature, the relative humidity, and the surface pressure. And we give it a title, we attach the legend, and we do the configuration of the plot, and then we'll be showing the plot. You'll see later on when we run the code again, the plot being generated. One of the required parameters for the Zambretti algorithm, it's the elevation of the location. In this case, we are going to be using the Open Meteo Elevation API to get that information. So it reserves some parameters also, which is the latitude and the longitude. Again, we'll be calling the request get with the elevation URL and the parameters, and that will return JSON response like before that we store in the elevation data. We extract the elevation information key, which is actually a list, but in this case we only pass one set of latitude and longitude, so we are interested in the first record. And if we have the elevation, then we just print that to the console. Either do we have the elevation for the location, or we don't have that data available. So now we actually can predict the weather with the Zambretti algorithm. So we're going to be extracting a subset of the entire data frame. In this case, we're only interested in the time and pressure columns, and we're going to be renaming that for ease of use as timestamp and pressure. And we're going to be dropping any values that are not filled in or empty, which should not be the case, but just to make sure. The Zambretti implementation that we are using, it receives these data points of time and pressure as a tuple, as a list of tuples. So we are converting that from the data framework conversion to a tuples, and we are converting that to a list of tuples. Obviously, we don't want the index, and we also don't want the name to appear, so that we have only the tuples values. Another parameter is the last temperature on that location. So we're also going to get from the data frame the temperature, the key, and we're getting the last value that was measured. So that will be the most recent value for the temperature. We print that to the console, and now we are ready to start preparing the data for the Zambretti algorithm. So it receives a pressure data object that is from the Zambretti API implementation, and that just pretty much is the list of tuples. So we just initialize that pressure data with the data points, which is the list of tuples from before. And now finally we can call the Zambretti algorithm. So we create an instance of the Zambretti algorithm object, and then we call the forecast method that receives as parameters the elevation and the temperature and the pressure data, which is always a list of tuples. We make sure that the elevation and the temperature are integer values, and then that the information, the weather prediction, is stored in the forecast variable, and we just print that information to the console. So now we can run our main.py file. It will be extracting information from the API, and it will be making a plot. As you can see, we're also doing a plot of the weather data of the past week. So you have the air pressure as green in this case, we have the temperature as red, and we have the humidity. And of course you can save and do all the normal things you can do with the Matplotlib plot. And if we close this, we see that has processed the rest. So we get the data, and then we're printing the head of the data frame, so the first record. Then we're getting the elevation, which in this case for the London location is 16 meters. The last temperature that was measured at today's date, it was 12.1 degrees Celsius. And the Zambretti forecast for this particular location is fine, possibly showers. And that is it. So this is how you can predict the weather with Open Meteo and the Zambretti algorithm. Give it a like if you like this video, subscribe for more content about Python, Django and AI, and until next time, happy coding!